So this is section 2.6, part 1. So in this video, we're looking at special cases, so special factors. Here when we have a difference of squares and when we have a perfect square trinomial. So this first, when we do a difference of squares, this is only the case when we have just just a binomial, two terms, okay? So whenever we have two terms, this is what we use. Now, normally you have three terms, right? An x squared, an x, and a number. So this is just going to be when you only have two. You do this special case, okay? So for this to work, both of your two terms need to be perfect squares. So what you're going to do is you're going to do the square root of the first term. So here you have x squared. So the square root of x squared is just x. To do the square root, you have whatever the exponent is. So here, these two cancel out and you have no exponent, but let's just say you were doing the square root of x to the 4. So in that case, it would become x to the 2. So it would cut whatever the exponent is in half, okay? All right, so we have the square root of x squared, that's x, and then we have the square root of 16, because that's our second number, 16, and that's gonna be 4, okay? So then we set this up. We have two brackets. We're gonna put x and 4 in both of them. So our two things that we square rooted. In one of them, we're gonna have a plus sign, and in the other one, we're gonna have a negative sign. Just like here, one is plus, one is negative, okay? And that's how we factor these, and that's the final answer. Let's try another one. So with these, just remember that you need to always look for a greatest common factor still. Okay, that's still an important step. So here, 81 and 49, there's no greatest common factor that we can take out. So our first step is going to be 81m squared. So you're going to put 81 in your calculator and do the square root of that. We get 9. And then the m squared, the square root of that is m. Root 49, square root of 49 is 7. So we're going to have two brackets. We're going to have 9m plus 7 and 9m minus 7. One thing that's important here is whatever is the first term in your question needs to be the first term in your bracket. So it doesn't matter if you have 9m minus 7, 9n plus 7, like the whole brackets can move around, but it is important that the m value is in the front of the bracket and the number by itself is at the back of the bracket. Okay, looking at this next one, so we have a letter and a letter, but they're different, okay? 162 and 2, however, we can take out a greatest common factor here. So we need to do that first. So we get 2 and then 81v squared minus w to the 6. Okay, so we divided everything by 2. And then I'm going to do the square root of 81v squared. So I'm going to get 9v. And I'm going to do the square root of w to the 6. So when I square root this, I just cut whatever the exponent is in half. So I get w3. So I need to write my greatest common factor out front, 2. Then I have 9v plus w to the 3. And I have 9v minus w to the 3. Okay, so here I removed greatest common factor. Okay, so that's important. All right. Next, this next one, 45 5, those are both divisible by 5. R squared, S squared, so there's not the same letter. So I forgot to write this step on the last one. So divided by 5, I'm going to remove greatest common factor first. So I take out a 5. This leaves me with 9R squared plus S squared. And then that's it. One important thing to note about all of these, they all have negatives. Okay, this is negative. If instead of a negative you have a positive here, then you can't use this method. And then that's your final answer. You can't go further than just taking out a greatest common factor. So in this case, this is your final answer. All right, I didn't circle these. That's our final answer. That's our final answer. So that's it. Since we have no way to factor a sum, which is plus, of squares. Okay, this is called difference of squares. Difference of squares, meaning this needs to be negative. You can't do it if it's positive. Okay, so let's do one last example. So first we're going to see, is there a greatest common factor that can come out of these? There is not. So we're going to do the square root of 16x to the 4. So square root of 16 is 4, and we end up with x squared. And we're going to do the square root of 1, which is just 1. So we write this as 4x squared plus 1, 4x squared minus 1. Now, if I look at these, hey, because we started with a 4x, we started with x to the 4, even when we cut that in half, this is still a perfect square here, okay? And if we check, well, this 4, if we square rooted 4, it still is a perfect square, and 1 is always a perfect square. So this, and this is a negative in here. So this, oops, this is another difference of squares. So I'm going to keep going here. Now I can't do anything to this first one because it's positive, but I can continue to factor the other negative one. This gives me 2x, and I still have root 1 is just 1. So for my final answer, I rewrite the positive one. That one didn't change because it was a positive. And then this second bracket here splits into 2x plus 1, 2x minus 1. And I can't go any further because my x here has no more exponent to have, okay? So only need to worry about this if you start off with an even number on an even exponent that is greater than 2. So it has to be even exponent. So this would work if it was, because it's a 4, okay? And this is your final answer for this question. Okay, so you're going to try for this one. Page 103, number 5, A to L. And that's it for this section.